So good afternoon, everyone, and welcome to this 18th session of this course. Today we are going to look at ARIZ. ARIZ stands for Algorithm for Inventive Problem Solving. So where TRIZ stands for Theory of Inventive Problem Solving, ARIZ is the algorithmic way of approaching problem solving in an inventive manner. So you've heard about ARIZ earlier? Anyone? I did mention it in the introductory lecture, but anyone explored about ARIZ, anything more beyond what I had shared? Okay, doesn't look like that. So ARIZ is one of the problem solving tools. See, in this time, we have already covered function oriented search, we have covered standard solutions, we have covered inventive principles. ARIZ is another problem solving tool. We will not really talk about smart little people or the library of scientific effects. So this is probably the last problem solving tool that we're talking about in this course. It stands, as I mentioned, for algorithm for inventive problem solving. And just like an algorithm, it lists a step, it is a list of step-by-step procedures that incrementally evolve a complex problem into a point where it is simple enough to solve. So I know many of you were struggling to define physical contradictions for your problem and stuff like that. So ARIZ asks you to answer a few questions, to formulate a few questions, to formulate a few problem statements in a particular format, so that physical contradiction automatically emerges out of the work that you do. So magic starts to happen as you start to apply. Just go through this algorithm step by step. So what ARIZ actually does is it helps to select the right set of TRIZ tools and use these in an effective sequence. That's what an algorithm is about. Then it's a multi-step process where we're asked a series of questions that integrate different TRIZ tools. And there are some rules, there are some notes which we'll talk about as we discuss more about ARIZ. The unique power of this is that it being a step-by-step process, which tool to apply is not something that you have to really think too much about. And ARIZ is automatically, the way it is defined, the way the questions will be asked, is geared towards achieving the ideal final result. What is the ideal final result? It's written on the slide also, but I want you to read it out or speak. What is ideal final result?
Possible solution.
Best solution to inventive problem.
So it is, so ideally, so whatever the problem is, in an ideal scenario, the problem should get solved and you should not be doing anything to the system. Like the system should solve the problem all by itself. The problem should get solved and no extra cost should be incurred. That is the way an ideal solution would come into picture. And it is also based on trends of engineering systems evolution that we discussed in the last class, which we know are objective trends and statistical trends. And therefore, since they are statistically relevant, the solutions are usually effective and reliable. Very interestingly, see, typically when you solve a problem, you're thinking of a converging funnel, is it not? We say that, okay, we will brainstorm, we will come up with lots of ideas, and these ideas will converge into one or two final good ideas. With ARIZ, what also happens is there is also a diverging funnel. So there is a converging funnel and a diverging funnel which get created simultaneously. The converging funnel transforms an unclear and fuzzy initial engineering situation into a very well-defined model of a problem by sequentially reformulating it as initially as engineering contradictions, then substance field models, and then as physical contradictions. So स्टेप बाय स्टेप आपको लेके जाएगा और इन तीनों तरह के एब्स्ट्रैक्शंस में आपकी प्रॉब्लम को डिफाइन करना शुरू कर देगा. This is a converging funnel. And there is another diverging funnel. That diverging funnel is of resources. So what it also does is it identifies additional resources that may be available in the system or the super system that could be used to solve the problem. So as you go deeper into applying ARIZ, you will see that the number of resources that you have available with you tends to increase. So the probability of getting a very interesting solution increases. Interesting? So as I said, there is one converging funnel where we start with a rough idea and move into the zone of a well-defined problem model. The other one is a diverging funnel, where initially हमें लगता है there are no resources to solve the problem. That is the primary reason there the problem is. But as we proceed through the ARIZ flow, we come to see that there are more resources and they can be used to solve the problem at hand. This consists of 9 parts that are organized into 3 main categories. And each part then again consists of many sub-steps. It's like a 9-step flowchart, which is organized into 3 sections, you may say. And each section or each category is like, you know, where we say that, okay, we restructure the original problem. See, that is what we were anyways doing. We had an initial problem. We did CEC. We said, okay, let us find out what is the root cause. Can we restructure the problem so that there is an easier problem to solve? We were doing a function analysis so that we could identify what element, what component is causing a harmful effect, or what component is doing insufficient action or excessive action. And we would solve only that problem then, so that the overall problem gets solved. We were already trying to restructure the problem. ARIZ is a way in which, or ARIZ is a flow chart which takes you through the same process in a what do you say, a simple way. Then the second aspect is removing physical contradictions. This again we have done. We were looking at removing technical contradiction, removing physical contradictions, doing function-oriented search, all that we were doing. And then analyzing the solution. So analyzing the solution is anyways the third part of the solution substantiation, where we say that if there are any secondary problems, we need to solve them. So that is what this is about. So in your projects, you may already notice that you started with one initial problem, and then as you proceeded, secondary and subsequently smaller problems appeared, which you are now trying to solve. And you could apply TRIZ to each one of those smaller problems also. So that is the third part of the solution there. So in the first stage, you essentially analyze the system. Okay, what is this engineering system about? This is like creating a function model of the system, doing the CECA analysis, cause effect chain analysis. Then you analyze the resources. You identify all the possible resources. Air could be a resource, gravity is a resource, so many things. You could just put forth every resource that you can think of. And very importantly, you define the ideal final result and formulate the physical contradiction. So this is the first stage where you restructure the original problem, where you say that ideally, I do not want to do anything, but my problem should be solved. I do not want to incur any extra cost, no extra cost, but the problem is solved. That is what is the ideal solution. So that is what we formulate. How we will reach there, we do not know, but at least we formulate what is the real ideal problem, ideal final result that we are looking for when we are trying to solve this problem. In the second stage, we actually resolve the physical contradictions that we looked at. In this stage, we also apply knowledge base, we apply effects, and we apply standards and principles. And then if we see that the problem is still not solved, then we change the mini problem. We change the problem again. We go back to first stage and change it so that we are able to solve it. Once we have a solution at hand, we analyze it. We analyze the removal of physical contradiction, that has it been really removed. Then we do what is called as super effect analysis, which is we see that are there other alternate benefits that this solution can offer to me. And in the final stage, we simply review all the stages of ARIZ, of all the stages that we have applied in the real-time application. A solution like moving it from the lab to the real application. So that is the last step. So how do we analyze the system? So this is largely about doing function analysis. It starts with identifying the main function of the engineering system, the components and the super system, and then you make the function model. Looking at the function model, you then arrive at the engineering contradiction. So I'm not hearing anything. Is it clear for all of us, or you're not getting anything? That is why no questions.
So basically we understood that it's a 9-step process and about the converging funnel. Basically, I think we can also use some example to maybe take step by step.
Yeah, we will go through an example, but let me just take you through the process. So समझ में आ रहा है अभी तक? That is what I can assume then.
Yes, sir. Yes, sir.
Okay. So the after that we analyze the system, we have done the function model, and we've done all of that. We then look at analyzing the resources. And resources in terms of everything. See, abhi tak when we are talking of resources, we're talking about system and super system components only. Now we talk of resources in terms of space and time also. So that when we arrive at a physical contradiction, we know which separation principle can be easily applied. Are you able to see this? See, when we arrive at a physical contradiction, abhi tak we simply said, okay, सबसे पहले space apply करो, फिर time apply करो, फिर relationship apply करो, फिर system microsystem apply करो, and so on. Over here, we already identify कि कौन सा resource anyways available है. Is there a resource of space available? Is there a resource of time available? What are the substances? What are the fields which are there available in the super system or the system? And then we move ahead. At least we record them. Then we look at what is the ideal final result. Over here, we kind of make the substance field diagram, and we reformulate it into a physical contradiction. And this kind of enables us to use the various tools that we have. In the fourth part, we expand the list of available resources, and okay, we apply small smart people method. So it seems I will have to introduce it to you if we are really going to apply ARIZ in the projects. Any one of your projects, if you apply ARIZ, then I can explain this thing to you when the need arises. Okay, I don't want to burden the entire class with this. Then applying the knowledge base, effects, standards, and principles. So the knowledge base is already available in the Tech Optimizer tool that I've shared with you. You can go to the tab where it says scientific library of scientific effects. That is the knowledge base that is being talked about, where we look at various scientific phenomena. For example, if you have to remove water from something, what all scientific principles could you use? For example, you could use capillary effect. For example, you could use centrifugal force. So these are the effects. We all know about these topics in science. We know capillary effect. We have studied about capillary effect in our school physics. We know about centrifugal force. But when the problem is at is on the door and we are trying to solve the problem, it may happen that some of these effects are hidden from our obvious worldview. So in part 5, we actually go and look at these effects in a structured manner, these scientific phenomena in a structured manner. And that is where Tech Optimizer can actually come in very handy for all of you. Then if it so happens that the solution is not there, we are not able to find a solution, then we change the mini problem and we go to step 1 again. We redefine the engineering contradictions. And finally, as I said, we analyze the solution where we expand its applications and see if the application of ARIZ could be improved. This part is something which does not require too much of an effort, but it's important to do. So this is how the flowchart would look like. You first analyze the system, model the problem, write the engineering contradictions, then you analyze the resources. What are the operating zones? What are the operating times? So we know that, okay, if the operating zone is different, then the separation in space is possible. If the operating times are different for the engineering contradiction that we were talking about, then separation in time is possible. And we list down, as I mentioned, resources of system, subsystem, supersystem, everything. We list down all the resources there. Then we formulate physical contradictions at the macro level and at the micro level, and also formulate the ideal final result. What is the ideal final result? Usually you will notice that ye karte mein hi, because you've done the operating zones, operating times analysis, and you're also keeping a view on the ideal final result, you may have a solution. If you have a solution, you directly go to the 7th step, you start to review the solution. If the solution is not there yet, then you try to resolve the physical contradictions, with the conscious effort. If the solution comes, again, directly jump to step 7. No, only then you apply the knowledge base and effects, standards, principles, etc. Abhi bhi solution nahi aaya, then you go to the step 1, change the mini problem all over again. And if you have the solution, you again come back to analyze the solution. Then you see, you answer a few questions. Has the IFR been met? Is it really the ideal final result? Is there no physical contradiction left now? Can it be implemented? Can the solution be implemented? If the answer is yes, you say, okay, develop maximum usage of the solution. If the answer is no, so you thought there is a solution, but the answer is no. So you come back to the first step. You reanalyze the system. You redefine the mini problem. Then you develop the maximum usage of the solution. Whatever solution you have arrived at, how can it be maximally utilized in the system? And then you review and you identify key learnings so that you can use them in the next problem solving experiment that you do. Any questions?